Okay, everyone, here we have trigonometry, and we're gonna start with a Cartesian plane. So what it's saying to us is, in the first quadrant, all the angles are equal. So all the angles of sin, cos, and tan, or cosec, sec, and cot, is positive in the first quadrant between 0 degrees and 90 degrees. Then, in the second quadrant, only sin and cosec is positive between 90 and 180 degrees. For the third quadrant, only tan and cot is positive between 180 and 270 degrees. Then, in the fourth quadrant, only cos and sec is positive between 270 and 360 degrees. Now we have our reduction formula in blue, and what this is telling us is, when we are given an angle and we need to reduce it, if the angle is between 0 degrees and 90 degrees, we write the angle as is. But when we're in the second quadrant and the angle is between 90 and 180 degrees, we say 180 degrees minus the difference of that number. So what I mean by that is, so here we have an angle that is between 90 degrees and 180 degrees. That's 150 here. So that means we're going to be in the second quadrant. And to reduce this 150, we must say 180 degrees minus a angle that will give us 150. So it's going to be 180 degrees minus 30 degrees will give us 150. The same goes for this 225 here. This 225 tells us we are in the third quadrant between 180 degrees and 270 degrees. So we have our reduction formula for third quadrant is 180 plus the angle. So we must now say 180 degrees plus what number will give us 225, and that's 45. Okay, so let us do the last one also, and it's saying 315. So 315 is between 270 and 360, and when we use the reduction formula, we say 360 minus what angle will give us 315, and that is 45. But let's see what we mean by applying it. So we said for this 150 in the second quadrant. So 150 tells us we are in the second quadrant, and we have sun. Now, how do we write this? We say 180 degrees minus the difference, or then the angle that will give us our 150. So 180 minus what will give us 150? 30. Now we have cos 225. 225 says to us that we are in the third quadrant, and cos is negative in the third quadrant. So we write it like this. Not yet, we don't have the signs yet. So let us say to ourselves, we have cos 180 degrees plus. Now we must say 180 degrees plus what angle will give us 225? That is 45. Now we have tan 315. So 315 is between the fourth quadrant. So we're gonna say 10 360 degrees minus. So 360 degrees minus what angle will give us 315? 45 degrees. Okay, now we have to apply the signs because we now learned that sin 180 minus 30 is in the second quadrant and sin is positive in the second quadrant. So we write this reduced angle now like this. We use 30 here, so we use 30 over here when we reduce it. Then cos 180 plus 45, 180 plus 45 is here in the third quadrant, but cos is negative in the third quadrant. So we write it like this. Again, you can see with the angle we reduced it with, we write, but this is called the reduction formula. So 360 minus, 360 minus is in the fourth quadrant, but we have 10, and 10 is negative here because only cos and sec is positive in the fourth quadrant. So we're going to write 10 45 degrees like that. So now we are going to need our special angles, and this over here is our special angles, our triangles, yeah. So we're using our triangles because they said we must do this without a calculator. So we are gonna do this. So we have 60 degrees and 30 degrees and a 90. We have 1 here for this side and we have a 2 for the hypotenuse. And then this side over here we have square root 3. The other angle we have a 45, a 45 and a 90. The hypotenuse is square root 2. And then the other side is 1 and a 1. This table very important to remember. Even though we can use our calculator, when we use a calculator, they'll be able to see. So we must know our special angles. Our special angles. So now we see that we have sin 30 over here. So sin 30 is a half times cos 45 is 1 over square root 2 with a minus, so it's minus 1 over square root 2. Tan 45 is 1 with a negative over here, negative 1 like that. So what I want you to do now is I want you to put cos 45 in the calculator. Then you see it will be square root 2 over 2. But we're using without a calculator. So what we're going to do is on the side we're going to do this. Then we're going to say this first space I'm going to do it like this. This is fractions. This is fractions what I'm doing here, this method. Equals the square root will cancel that square root. So we're going to be left with 1 over 2 times negative square root 2 over 2 over negative 1. equals negative square root 2 over 4 over negative 1. This will equal square root 2 over 4. Why I did this here, so square root 2 over square root 2 is because we need to simplify this whole fraction. And to do that, we need to get rid of the square root at the bottom, so we can add and subtract this one, not subtract, but multiply improperly. When you put cos 45 in your calculator, you will get this answer immediately. That's why you must do this step. You must do this step because they will know you're doing this calculation with your calculator. But the question said without the calculator. So you must do this to give you this. Then you simplify from there. So 1 times square root 2 is square root 2. 2 times 2 is 4. And that negative stays. This negative and that negative will cancel, and it's over 1. So we can write it like this. Okay. So we didn't touch on this one yet, but it's straightforward. So cosec is the inverse of sine, and sine is the inverse of cosec. So cosec equals 1 over sine x, and if we do the opposite is, let me say, sine x equals to 1 over cosec. If we cross multiply to get sin x as the subject of the formula, then sec is the inverse of cos, cos is the inverse of sec, cot is the inverse of tan, and tan is the inverse of cot. And now we know that these two go together. We look at the third letter of cosec, the third letter is S, and we only have sine that has a S. Same way with sec, the third letter is a C, and we have cos that goes cot is tan because the third letter is a T, so 1 over tan is the inverse. Very straightforward. So the next question, we must know our Cartesian plane. So let's quickly roughly draw our Cartesian plane. So we have our reduction formulas, 180 minus, and then that's at the bottom here is 180 plus, then here is 360 minus, this is our 90, our 180, our 270 degrees, 0 degrees, and our 360 degrees. All is positive here. Sin and cosec is positive here. Tan and cot is positive over there. And then cos and sec is positive here. I urge you to always do this next to your equation when you get your paper and you're about to write and you're starting. When you do trig, write this down. It'll be your best friend, it'll be your best guide. So how do we apply this now? We look at this over here. We don't have angles now, but we have the reduction formulas. So the angle will always tell us in which quadrant we are working. And we're working with a quadrant that has 360 minus 8 minus an angle. So this is the fourth quadrant. and we have a cos. So cos is positive in the fourth quadrant. So we write it like this. Next one, tan 180 plus a. So we look at the angle first to say what quadrant we're in. 180 plus is the third quadrant, and we have a tan, and tan is positive in the third quadrant. So we write it like this. Now we have a sin squared, but don't worry about the squared. We just look at the angle again. The angle is 180 plus a. This is in the third quadrant again, but sin is negative here because only tan and cot is positive. So we write it like this. We say negative sine a squared plus we have a 360 minus a. This is in the fourth quadrant and it's a cos squared, but we ignore the squared for now. So we're gonna write it as cos a squared like that. So let's just make this nicer. So we have cos a tan a. So how we write this now is we say so this is in brackets. So we know when it's squared, it's times 2. So a negative sine a times a negative sine a is a positive sine squared a plus a cos a times a cos a is a positive cos squared a like that equals. So now we must know that we have identities that exist. So one of our identities says that a sin squared a plus a cos squared a equals to 1. This is one of our identities. We have quite a few, but we will get to them. Let's do it step by step. So here we can see we have a sin squared a and a cos squared a. That means that this whole denominator we can say equal to 1. So we can say cos a times tan a over 1 equals cos a times tan a. Are we done yet? No, we're not done yet because this is not an identity, but tan a equals sin a over cos a, and cot a equals cos a over sin a, just so you know. So what does this mean? This means that we are simplifying this equation to the maximum, like to its maximum point that it can't anymore. So this also just proves that cot is the inverse of tan and tan is the inverse of cot because tan is sin over cos and cot is cos over sin. This just proves that it's the inverse. But let's continue this here. So we're gonna break up the tan and we're gonna say sin a over cos a. This will cancel that and that will cancel. Then we are left with sin A. Very important to remember is this one over here. Identity is also very important to remember. And my Cartesian plane. That we must know. That we must know. Okay. Our next, before we go to the next one, I wanna show you that we're gonna have to manipulate many of our identities, many of our angles like this over here, like we did here now, and the identities can be written like this also. 1 minus and sin squared A equals to 1 minus. This is how we must manipulate and use what we can and what we have been given to solve equations. So this is trigonometry is very much manipulations, very much manipulations of identities and angles we are given. Okay, our next our next one is to simplify and prove. Is to simplify and prove. So simplify and prove. This one we are gonna simplify, but we don't want a sec or a cot here. We want a cos. We want to work with cosine and tan. We don't want to work with sec and a cot like this. So what do? We say 1 minus cos beta 1 plus 1 over cos beta, because 1 over cos is the inverse of sec, and then cot, we learned that it is cos beta over sine beta, like that. So to make this easy on ourselves, we are gonna multiply this bracket with this bracket, and then we leave this one for last. So cos beta over sine beta times 1 is cos beta over sine beta. Cos beta over sine beta times 1 over cos beta equals, this will cancel with that one. It will be 1 over sine beta, like that. Now we multiply this one with that bracket. But we know we can now simplify this because the denominators are the same. So let us quickly do that. We can have cos beta plus 1 sine beta. Now we can multiply. So we're going to have 1 times cos beta, 1 times 1 is a positive 1. Negative cos beta times cos beta is negative cos squared beta. Negative cos beta times 1 is a negative cos beta. All this over sine beta. Okay, so this cos beta will cancel with this positive cos beta, so this one is negative. Then we are left with 1 minus cos squared beta over sine beta. So, how do we simplify this? We must remember our identity that we manipulated. So we have 1 minus cos squared beta, and our identity is saying 1 minus cos squared beta equals to sin squared beta, our angle. So we can write this as sin squared beta over sin beta. I said that we're going to manipulate our identities all the time. And as we did here, 1 minus cos squared beta gives us sin squared beta. So we know that this will go away and we're going to be left with only sin beta. Because 1 sin beta will cancel with 1 of that sin beta that's there. Okay. Our next one. We must prove that everything on the left hand side of the equal sign equals the right hand side. So we say like this, left hand side equals. So are we going to start this? We're going to start by saying that sin A times cos A is sin A cos A. 1 times 1 is 1. 1 times negative sin A is negative sin A. Sin A times 1 is a positive sin A. Negative sin A times sin A is a negative sin squared A equals to sin A times cos A over 1. So this negative sin A will cancel that positive sin A, then we're left with just 1 minus sin A, sin squared A. Okay, and we learned now that this is one of our identities. So which identity is that? It is. So that's what we have. So 1 minus sin squared A is cos squared A. And I got that from my identity. So this is the original identity that we manipulate. Where we see 1 minus sin squared A, like over here, equals to cos squared A. That's why it's cos squared A here. This is how we're going to manipulate all the time. So, what do we have now? What we have now is, okay, so the next one is saying, when we start this, we're going to say sin A times cos A. So we say left hand side. So we must prove the left hand side is equal to the right hand side of the equal sign. So we say left hand side, and then we say sin A times cos A is sin A cos A over 1 times 1 is 1. 1 times negative sin A is negative sin A. sine A times sine A times 1 is a positive sine A. Sine A times negative sine A is negative sine squared A, like this, equals to sine A times cos A over 1. So we see that this negative sine A and that positive sine A will cancel each other. You're left with 1 minus sin squared A. And now what I wanted to see now is that this is from our identity. Here's our main one, sin squared A plus cos squared A equals to 1. Then we will manipulate this to give us cos squared A and a sin squared A. So we see that we have 1 minus sin squared A, and 1 minus sin squared A equals to cos A. So we're going to write this as cos squared A. Always we will do this, always, by manipulating what we have here to give us something else that's more simplified. Okay, we continue, and then that cos A will cancel with one of the cos there at the bottom to leave us with sin A over cos A. And we must now recognize that sin A over cos A, sin A over cos A equals to tan A. And what do you know? Tan A is on the right hand side. That means the left hand side equals the right hand side. We have now proved this correct. So always we will manipulate and simplify what we are given, like here and over here, to give us a more simplified version. Okay. This next question is the same. We must prove the left hand side and the right hand side. So sometimes we're not always going to use the left hand side. We're going to use the right hand side. So the left hand side, we know that in the fourth quadrant, cos is positive, and this is 360 minus A. 360 minus A is telling us that this is the fourth quadrant. And so 360 minus A, we're in the fourth quadrant, and cos is positive in this fourth quadrant. So we can simplify this and reduce it to say positive cos A. So we must prove now that this right hand side is equal to this cos A over here, which we can't prove with this angle's looking like this. So we must now first reduce it. Always reduce first your angles, then you can continue solving. So now we say right hand side. Right hand side is 1 minus. So according to our Cartesian plane, 180 plus is in the third quadrant, but we have a sign. That means sign is negative. So we're gonna write it like this. We're gonna say negative sine a squared like that over 1 minus. Okay, now we're gonna have 180 plus. For cos over here, we have 180 plus, so we're in the third quadrant, but it's a cos, and cos is negative here in this quadrant. So we write it like this, cos A equal. So this squared inside here, sin negative sine A times negative sine A is a positive sin squared A over negative times negative. That's negative and that's negative give us a positive, so it's 1 plus cos A equal. So we're now going to use our identity because we have a cos at the bottom. So what we want to do is we want to cancel this 1 plus cos A and get it away. And the only way we can do this by simplifying this sine squared. And if we can remember our identity, we can say sine squared A equals 2. We can say 1 minus cos squared A, 1 plus cos A. So we're going to go back and forth like this with our identities. And if we know our mathematics, 1 minus cos squared A is difference of two squares. So we can say 1 plus cos A multiplied 1 plus with 1 minus, this is a minus, with 1 minus cos A over 1 plus cos A. So now this will cancel with that one over there and will leave us with 1 minus brackets 1 minus cos A equals 1 minus 1 plus cos A when we multiply this negative in, and then this one and that one will cancel. Then we're left with cos A equals the left hand side, and this is the right hand side. So left hand side is cos A, and here we have cos A. We have proved it. We have proved it. So the next one, we're gonna use the left hand side to prove the right hand side. So how do we start this? We must now expand this bracket over here, and we do that by doing this. So we're going to say 1 minus, we're going to say sin theta cos theta sin theta cos theta, all this over sin theta equals, so 1 minus in brackets sin theta times sin theta is sin squared theta. Sin theta times negative cos theta is negative sin theta cos theta. Negative cos theta times sin theta is negative sin theta cos theta. Negative cos theta times negative cos theta is a positive cos squared theta. So I've got a space there over sin theta equals to 1 minus sin squared theta minus 2 sin theta cos theta plus cos squared theta over sin theta. It's just simplifying it nicely for us. So we know identities now is saying that a sin squared theta plus a cos squared theta equals to 1. That means we can write it as 1 minus 2 sin theta cos theta over sin theta like that. When we multiply this in, we're gonna get 1 minus 1 plus 2 sin theta cos theta sin theta. Okay. Then we're gonna have this one cancel with that one, and then this for space. This sin theta will cancel with that sin theta. Then we'll be left with 2 cos theta equals the right hand side. 2 cos theta and 2 cos theta. Left hand side equals right hand side. Okay, we have more. We have more. So that's what we're saying, simplify. So we simplify this by using our laws of our fractions, and we're now gonna multiply the denominators together. So 1 plus cos x in brackets times sine x. So this fraction doesn't have a sine x, so we multiply this with a sine x, plus this fraction doesn't have a 1 plus cos x, so we say 1 plus cos x multiplied with 1 plus cos x. So now we just expand, then we're going to say sin squared x plus 1 times 1 is 1, 1 times cos x is cos x, plus cos x is 2 cos x plus cos squared x. This is just expanding. And then the bottom we leave as is 1 plus cos x. The denominator we stay the same like that. So again, we have a sin squared x plus a cos squared x is 1 because of our identity. So it's 1 plus this 1 plus 2 cos x over 1 plus cos x sine x equals to 2 plus 2 cos x over 1 plus cos x sine x. Now we're going to factorize out this 2. We're going to get 1 plus cos x over 1 plus cos x sine x. So this 1 plus cos x will cancel with this 1 plus cos x over there. And then we're going to be left with 2 over sine x. And they said simplify. So we can still simplify this further. Because we learned that 1 over sine x equals to cosec. That means 2 over sine x will equal 2 cosec x. So 2 cosec x. That's our final answer. So this next one is saying 1 over cot A plus 1 over tan A. So we're now gonna simplify this cot and this tan to say 1 plus cos A over sine A over 1 plus sin A over cos A equal. So how do we do this now? We do fractions and we say the top, we do the top first. We say the denominator for the top is sin A over sin A plus cos A. For the bottom, we have cos A. So this fraction, or if we convert this, it's going to be cos over cos. This is sine over sine. That's why we have a sine here and a sine here. So here we will have a cos A plus sine A equal. Now we're going to do a cos A sine A multiply by the inverse, because this is divide. We always divide, and when we divide fractions like this, we can do the reciprocal of the last or the bottom fraction. So we're gonna have cos A plus sine A equals. So this sine A is positive, and that sine A is positive, that cos A is positive, this cos A is positive. So these will cancel. Then we're gonna have a cos A over sine A. And we know now that this is equal to cot A. Always we will do it like this. No matter what you get, we will be doing it like this. We have a few more. So how do we start this? We start this like normal fractions. We're gonna multiply the numerators together. We're gonna get cos A. The denominator we multiply together, we get 1 times 1 is 1. 1 times negative sine A is a negative sine A. Sine A times 1 is a positive sine A. Sine A times negative sine A is a negative sine squared A. I think we got the question on this already. Equal to cos A over. This one will cancel with that one. Then we're left with 1 minus sin squared a. And we know now that this here equals cos squared a because of our identity. Then this cos a will cancel with one of the cos a's there to leave us with 1 over cos a. But we want to simplify this as far as possible, and 1 over cos a we know is equal to 1. 1 over cos a equals to sec a. And that's our final answer. For the next one, we need 2 more identities. We need 2 more identities. And the identities we're going to need is, I'm going to say here, we're going to be introduced to now a new identity. And the identity is saying tan squared theta plus 1 equal to sec squared theta. That means that tan squared theta equals to sec squared theta minus 1. Okay, so what do we do now? We must prove that the left-hand side equals the right-hand side. So we can use either one, left or right, and we will still get the correct answer. So let us use the left-hand side. Left-hand side. So let us see. So we're gonna have sec to the power 4 and sec to the power 2. So we can factorize out a sec squared and have a sec squared theta minus 1 like that there. And we must now recognize that this sec squared theta minus 1 is that one over there. So we can write this like, we can write this back part we can write like this. We can say tan squared theta. This front part is that one over there. So we're gonna write it as tan squared theta plus 1. Now all we do is multiply this tan squared with that tan squared to give us tan 4, and that tan squared times that 1 will give us tan squared theta, and it's equal to the right hand side. So let us just quickly see that if we use the right hand side first, we're gonna have to factorize out the tan squared again, and when we do that, we're gonna get tan squared theta plus 1, and tan squared theta is equal to sec squared theta minus 1, and tan squared theta plus 1 equal to sec squared theta. And then multiply this sec squared in with this sec squared here, or leave it with sec 4 theta. And then sec squared times that negative 1 is negative sec squared theta. And then you can see that this is equal to that over there, equal to the left hand side. Not always you can do this because depending on what is on the left hand side and what's on the right hand side, you can't do both. You must pick one that you can manipulate because that's over here. You can't manipulate those two costs into anything, only this one here. Same with this over here. You can't manipulate this any more than this reduction formula here. So you have to use this one. You have to manipulate this one into the left hand side. And this you must manipulate into this left hand side here again, into the right hand side. You can't manipulate two cos theta into anything. So you must use this side. Here you can't use anything with the left hand side. So you must use the right hand side. But here you can use both sides. Here you can use both sides. And that is this piece of trick, simplifying and proving.